Surface area volume, exercise 13.2. Now see the questions in 13.2. A solid is in the shape of a cone standing on a hemisphere. So this is a cone standing on a hemisphere with both radii equal to 1 centimeter. So the radius of the hemisphere as well as the cone is 1 centimeter. The height is also equal to the radius. That means the height is also equal to the radius, which is equal to 1. Find the volume in terms of pi. We don't have to substitute the value of pi. The answer has to be given in terms of pi. So as discussed earlier, if there are two figures, we'll have to add the volumes of the two figures. And the volume of a hemisphere, this is 2 by 3 pi r cube, and volume of the cone will be 1 by 3 pi r square h. So 2 by 3 pi r cube, that is the formula here, right? So 2 by 3 pi r cube will be the formula of hemisphere volume, and volume of a cone is 1 by 3 pi r square h. Okay, always write the formula, it's better. And then you will substitute the radius as 1. So we get 2 by 3 pi, because 1 into anything will be the number itself, plus 1 by 3 pi r square h. The radius and height are all 1. So 2 by 3 plus 1 by 3 pi, we get 3 by 3 pi, right? When you solve this, you are going to get 3 by 3 pi. So 3 gets cancelled. And the volume we get as pi centimeter cube, right? So this is the final answer because they have expressed, they have told us to express the volume in terms of pi. So you need not solve this further. Then we move on to the second question. In the second question, Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at the two ends. So what is happening is we are having a cylinder with two conical ends like this. The diameter of the model is 3. So if diameter is 3, the radius is going to be half of that. So radius will take as 3 by 2 and the length is 12. This total length is 12. Find the volume of the air contained. So we have to find the total volume here. So first of all, this total length of this model is 12. So the radius is 3 by 2, that is 1.5, right? So what we need to do is understand here that the radius here is 1.5 and the height of the cones are 2 each. So this height is going to be 2 and this height is also going to be 2. So what's going to happen here? The total 12, we'll have to subtract this 2 and 2. So 12 minus 4, that's going to be 8. So this is going to be the height of the cylindrical part. Okay, so 2 height of the cylinder, 2 height of the cone, and 2 height of the cone is going to be subtracted from either ends. So 4 will be subtracted. So 12 minus 4, we get 8. So what is going to be the volume? Volume will be 2 into 1 by 3 pi r square h, because there are two cones, plus the cylinder pi r square h, right? So pi r square we can take common. So we are left with 2 by 3 h1 plus h. The heights are different. So when you talk about h1, we are talking about the height of the cone. And when we are talking about h, we are talking about the height of the cylinder. So here we get pi r square. That is, we have taken common. So 2 by 3 into 2 plus 8. This is 4 by 3 plus 8. So we'll take the LCM here. You get 28 by 3. And now it's just a matter of cancelling all this. So 7 goes 4 times. This 4 and 4 gets cancelled. This goes 3 times. So 22 into 3, we get 66 centimeter cube. So that will be the volume of air contained in this model. Right? So if you compare these questions with the area questions which we did in the previous question, these are easier because there at least you had to distinguish in which one you had to use lateral surface area and which is total surface area. But in volume, you don't have any problem. There's only one formula to be applied. Okay, moving on further. Question number 3, we are going to start. This is question number 3. You can mark this important. Gulab jamun contains sugar syrup up to 30% of its volume. Okay, so you know gulab jamuns, it's full of sugar syrup, 30% of its volume as specified. So in this tin, there are 45 gulab jamuns, each shaped like a cylinder. Okay, this is a cylinder with 2 hemispherical ends. So this is a cylinder with 2 hemispherical ends. And the dimensions are given that the hemispherical ends with length 5 centimeter and diameter is 2.8. So the entire length of this gulab jamun is 5, and what is given, diameter is 2.8, so radius is going to be 1.4. So when the radius is going to be 1.4, the height of the hemisphere and radius are always equal. Please remember that. So this is 1.4, 1.4, 2.8. So 5 minus 2.8, you will get 2.2. Okay, so that is very crucial for the sum, that we understand this concept, that this radius is 1.4 and this radius is also 1.4. That is actually the height of the hemisphere, because in a hemisphere the radius and height are same. This is also radius only. So this is going to be 1.4, 1.4, 2.8. Total was 5. So 1.4, 1.4, when we add 2.8. So 5 minus 2.8, you will get this 2.2, right? So now let's calculate the volume of one gulab jamun. That is, we are going to apply the formula pi r square h plus, this is 2 by 3 pi r cube into 2. So 2 by 3 pi r cube into 2. Why? Because there are two hemispheres, plus pi r square h. Pi r square we can take common. So we are left with 4 by 3 r plus h. Pi value 22 by 7. Radius is 1.4. 4 by 3 into 1.4 plus 2.2, right? So we have to solve this. So this can be 22 by 7 into 1.4 into 1.4. I can write like this so that I can cancel this. This will be 0.2. And if I am going to solve this, first multiply this, okay? This will be 5.6 by 3, okay? I'm multiplying 1.5 plus 2.2. So we will take LCM here. This, of course, I can write it as 4.4 into 1.4. And this will be 6.6 plus 5.6. That is 12.2 upon 3. So this is going to be the calculation. You will have to first multiply 4.4 into 1.4 and then multiply it by, this is going to be 12.2 and divide the result by 3. So when you do all that process, you are going to get 25.07. 25.07. So 25.07 is the volume of one gulab jamun. So what we'll do, we'll multiply by 45, because according to the question, there are 45 gulab jamuns, and then find 30% of that. That is 30 by 100 into 45 into 25.07. So when I calculate this, of course, I can cancel the 0 here. I can multiply 3 into 45 into 25.07. That will come 338. 3,384.45 divided by 10, and that's how you get, when you divide by 10, you'll get 338.445. So approximately, okay, that will come 338 centimeter cube. So the process is very clear, I suppose. First, we are calculating the volume of one gulab jamun, multiplying by 45 and taking 30% of that. You will be able to get the answer as 338.445, which is approximately 338 centimeter cube. Then question number 4. This is a pen stand made of wood, and this, the shape of this is given as a cuboid. And then what is happening? There are 4 conical depressions to put these pencils and pen or whatever. Okay, so this is a cone. So that much part of the wood is removed. The question is, what is the volume of the wood? So volume of the wood will be the volume of the cuboid, that is LBH, minus the 4 cones. So what will happen? We are going to use the formula length into breadth into height. So volume of the cuboid, we are using LBH. So when I calculate LBH, the total is 525. Okay. From that, what is happening? You are subtracting the 4 cones. So 4 into 1 by 3 pi r square h. 4 times 1 by 3 pi r square h. Because there are 4 cones, I am using 1 by 3 pi r square h. The radius is already given as 0.5, and the depth, which is actually equal to the height, is 1.4. So I'm calculating this 4 into 1 by 3 pi r square h. I'll get 1.47. So the total volume of the wood is 525, and the 4 cones together is giving me 1.47. So when I subtract this, I'll get 523.53. Okay, this will be the volume of the wood that will be on the stand. Moving on to question number 5. A vessel is in the form of an inverted cone. The height is 8 and the radius of the top, which is open, is 5. It is filled with water. When lead shots of radius 0.5 are dropped, then 1/4 of the water is flowing out. So according to the question, what is happening is that a vessel is in the form of an inverted cone. So this is the cone, and what is happening? This is filled with water and you are putting spherical shots. And what is happening? 1/4 of the water is flowing out. So we have to find how many lead shots or spherical lead shots were put in that so that 1/4 is flowing out. So first you'll have to find out the volume of the water flowing out. That is 1/3 pi r square h. That is the volume of the cone, and take 1/4 of that. So 1/4 into 1/3 pi r square h. Okay, so this is going to be the volume of water that is coming out or flowing out, because 1/3 pi r square h is the volume of the water, and the full water is not coming out, only 1/4 is coming out. So I'm calculating that, right? And the volume of the sphere is 4/3 pi r cube. Volume of the sphere is 4/3 pi r cube. So what will I do? I will find out 4/3 pi r cube. So I need not calculate that value of pi, because pi will get cancelled. Okay, so when we are having 1/3 pi r square h, okay, 1/4 of this divided by 4/3 pi r cube, this pi is going to get cancelled. The 3 is also going to get cancelled. And now I will solve this. Of course, all the dimensions are given to you. And when you solve this, you should be able to get 100 lead shots. Okay. So it's a pretty easy calculation. If you want, I can put it on the whiteboard for you. So number of lead shots, I am going to apply 1/4 of the volume, that is 1/4 of 1/3 pi r square h divided by 4/3 pi r cube. So as I told you, pi and 3, pi by 3 is getting cancelled, 4 is not getting cancelled, sorry. Pi by 3 will get cancelled. So this is as it is, 4/3. Now I'm going to substitute the values. So what were the values here? If you look at the cone, the dimensions are, the height is 8 and the radius is 5. Height is 8 and the radius is 5. So this will be 1/4, 5 into 5 into 8. And this will be 4 into radius of the, this is for the hemispherical lead shot. That was, I think, 0.5, isn't it? Yeah, 0.5. So 0.5 into 0.5 into 0.5. So this I can cancel here 2 times. 5 into 5, 25, 25 into 2, I'm getting 50. So this will be 4 into 5, 5, 25, 25 by 125, 0.125, right? So number is going to be 50 divided by, when I calculate this, I'm going to get 0.5. So this will be 500 by 5, and therefore we get 100. Okay, so this is the way we calculate how many lead shots. So total volume of water that is flowing out and divided by the volume of one spherical lead shot will give you the number of lead shots. Right, so then we move on to question number 6. This is question number 6. This is a solid iron pole. This is a solid iron pole consisting of a cylinder of height 220. Okay, the height of this is 220, diameter is 24, that means the radius is 12. Surmounted by another cylinder of height 60 and radius 8. So there is one big cylinder and one small cylinder of different dimensions. This is height 60 and radius is 8. Question is, find the mass of the pole if 1 centimeter cube of iron is 8 grams. So we have to find the mass. So first what we'll do, we'll find the volume of these two parts, add it up to get the total volume of the iron, and multiplied by 8. That will give you the mass of this in grams, and divide by 1000, you will get in kg. And they have specified, use the value of pi as 3.14. Okay, so we are going to use the formula here, pi r square capital H, that is the volume of the big one, plus pi small r square and small h, that is for the smaller one, right? Pi r square h. And so what we can do is take pi common and substitute the values. So capital R is how much? Capital R is the radius of the big one, that is 12. So 12 square into height is 220 plus pi into R square, radius of the small is 8 and height is 60. So 8 square into 60. So when I solve this, I will get 31680 pi plus 3840 pi, that is 35520 pi, right? And pi value they are asking us to use 3.14. And we get the mass by multiplying by 8 grams. And we are converting into kg by dividing by 1000. So 35520 into 3.14 into 8, I would have gotten grams, and I'm dividing by 1000. I will get the answer in kg. So what will be the final answer? 892.26 kg. That will be the weight of this total, the mass of the total iron. Okay, so we go to the seventh question now. A solid consists of a right circular cone of height 120 and radius 60 standing on a hemisphere of radius 60 is placed upright in a right circular cylinder full of water. Okay, so as per the question, there is a cylinder and the cylinder is full of water, filled with water. Now what is happening? There is a solid consisting of a cone and standing on a hemisphere. So inside, although it is water, there is a solid. So the water is going to occupy only the remaining part. So this is our cylinder. So inside, it consists of a cone standing on a hemisphere. So this is the hemisphere and this is the cone. So what is going to happen? Water is only going to be on the remaining empty spaces. The water is going to occupy only the remaining empty portions. So question is, find the volume of the water left in the cylinder. So what we need to do is find out what is the volume of the cylinder, the full cylinder, that is pi r square h. So the height of this is given, let's see, the radius is given 60. Okay, radius is going to be 60. The height of the cone is given 120. Height is given 120. And find the volume of the cylinder. Okay, and the radius is given 60 here. So what will happen to the height of the cylinder? Height is going to be, this is 120 up till here plus 60. So 180 will be the height of the cylinder. Okay, that is given to us already. Even if it was not given, we could have determined that because height of the cone is 120 plus the radius is equal to 60. And we know that radius and height of a hemisphere are same. So 180. So pi r square h, that is the formula that I'm going to apply here. Pi r square h, radius is 60, height is 180 for the full cylinder. And what do you have to do? You have to subtract both these because these are the figures which are put inside the cylinder. The water is not present there. So we'll have to remove that portion because the solid is occupying that space. So what are the figures here? One is the hemisphere. So that is 2 by 3 pi r cube. And this is 1 by 3 pi r square h. That is the cone. So that's what we are doing. This is the volume of the cylinder. You are subtracting 2 by 3 pi r cube, radius is 60, and 1 by 3 pi r square h for the cylinder. So when I calculate that, I'm going to get the volume of the water that is going to be left behind. So when you calculate that, you get 1.131 meter cube. And here the value of pi they have not specified, so you can use 22 by 7. Okay, so when you subtract this, actually here, when you are solving this 3 we can cancel here. 372, yeah. And this also you can multiply and subtract. So here we are getting this answer. This is in centimeter cube. Okay, this is in centimeter cube. How do you convert into meter cube? 1 meter is 100 cm. So when you want to convert centimeter to meter, we divide by 100. But centimeter cube to meter cube, we'll have to divide by 100, 100, 100 3 times. Okay, centimeter cube to meter cube, we'll have to divide by 100 3 times. So that means you'll have to shift the decimal 3 times to the left. 1, 2, 3, 4, 5, 6. That's why we get the answer 1.131 meter cube, right? The last question of that exercise is question number 8. Yes, this type of figure you must have seen in the chemistry lab. This is a round bottom flask. So this is a spherical shape, and here we have a cylinder. The neck is cylindrical. The dimension, the height of the cylinder is given 8 and the diameter is 2. So radius is going to be 1. And here the spherical part, the diameter is 8.5. Now, what is the question? A child is measuring the amount of water. Okay, how much water is there by actual measurement. And when you're measuring, the child finds it to be 345. Now you have to verify whether this 345 that the child has calculated is right or wrong. So let's find out by actual calculation now. One was by measurement. Now let's see whether the child has measured correctly or not. So the volume of the sphere, that is going to be 4 by 3 pi r cube. Volume of the cylinder will be pi r square h. So we are going to add 4 by 3 pi r cube and pi r square h. But remember, the radius is different. The radius is here, it's going to be wider. So radius is 8.5 by 2, right? And the radius here is 1. So when we are going to take common, only pi will be common. So 4 by 3 pi r cube plus r1 square h. 4 by 3 into, as I told you, this is the diameter. So radius will be 8.5 by 2 whole cube plus, this is easy because this will be 1. So 1 square into 8. So when we calculate this part, this is 2 square, that 4. So 4 is going to get cancelled. And when we solve this part, you're going to get 110.35, this whole thing. And multiply by 3.14 because they have specified the value of pi here as 3.14. So what is happening, the whole calculation you should get 346.5. And the measured volume by the child was 345. So there is a difference of how much? About 1.5, 1.51 in fact, to be very precise. So there's a difference. So we can say that the child did not measure correctly. If there is a difference of less than 0.5, then we'll say, okay, that is negligible. But here the difference is more than 0.5, right? There's a difference of 1.5 centimeter cube. That's quite a lot. So we'll say the child did not measure correctly. Okay, so that's the end of this exercise.